We know that covalent compounds are the compounds formed by the sharing of electrons. Let's see what are the different conditions required for the formation of covalent compounds. The first condition is that both the atoms should have a high ionization enthalpy. Ionization potential or ionization enthalpy is the energy required to remove an electron from an atom. So when both the atoms have high ionization potential, they cannot lose the electrons easily. Since they have to share the electrons, both the atoms should have a high ionization potential. Let's see how ionization potential varies in a periodic table. When we move from left to right in a periodic table, the ionization potential increases. And when we move from top to bottom in a group, the ionization potential decreases. Another important factor for the formation of a covalent compound is that both the atoms should have high electron affinity. Electron affinity, as the name suggests, is the attraction for electrons. So this is the amount of energy released when electrons are added. Since now in covalent compounds there is sharing of electrons, so the essential condition is that both the atoms should have a high electron affinity, so that both of them can equally share the electrons. Let's see how electron affinity varies in a periodic table. When we move from left to right in a periodic table, the electron affinity increases. When we move from top to bottom in a group, the electron affinity decreases. The third important condition for the formation of a covalent compound is that the electronegativity difference between the two atoms should either be zero or negligible. Electronegativity is the tendency to attract the shared pair of electrons. Since covalent compounds require the sharing of electrons, so the electronegativity difference between the two atoms should either be zero or it should be negligible. Now let's see how electronegativity varies in a periodic table. When we move from left to right across a period, the electronegativity increases. And when we move from top to bottom in a group, the electronegativity decreases. So these are the three important conditions which are required for the formation of a covalent compound, and the variation of these three in the periodic table is very important. Now let's take an example. We have hydrogen. It combines with fluorine. Hydrogen has 1 valence electron. Fluorine has 7 valence electrons. We know hydrogen behaves like halogens. So the ionization potential, electron affinity and electronegativity shows the same trends as in case of halogens. So they form a covalent compound. Both of them need 1 electron each. So they share 1 electron. By doing this, hydrogen has a duplet structure and fluorine has an octet structure. Now what do you think? They are sharing 2 electrons. Are these 2 electrons being equally shared by the 2 atoms? Let's see. If there are 2 dogs, both of them have 1 bone each, and if they fight, well, the stronger dog tends to pull the bones more towards himself. Similarly, in case of a covalent compound, when there are 2 different kinds of atoms, depending on the electronegativity, we know the electronegativity is the tendency to attract the shared pair of electrons. In this case, fluorine has a higher electronegativity than hydrogen. So fluorine tends to attract the shared pair of electrons more towards itself, and in doing so, fluorine gets a slightly negative charge and hydrogen gets a slightly positive charge. Since now there is a separation of charges, so such covalent compounds are known as polar covalent compounds, as they lead to the formation of poles. Whenever there are 2 different kinds of atoms forming a covalent compound, depending upon the electronegativity, one atom tends to attract the shared pair of electrons more towards itself And in this case, fluorine gets a slightly negative charge, hydrogen gets a slightly positive charge. So the covalent compounds are said to be polar. They are polar only when the shared pair of electrons are not at equal distances between the two atoms, as one atom tends to attract the shared pair of electrons more towards itself. Let's take an example. We have nitrogen atom. It has 5 valence electrons, so it needs 3 more electrons. This is done by sharing 1 electron with each of the hydrogen atom. So now it forms ammonia, that is NH3. Nitrogen in this case has 8 electrons, and each hydrogen atom has a duplet structure. That is, it has 2 valence electrons. Now, this ammonia that is formed, we know nitrogen has a higher electronegativity than hydrogen. So now nitrogen tends to attract the shared pair of electrons more towards itself. So it gets a slightly negative charge, and the 3 hydrogen atoms get a slight positive charge. So ammonia is a polar covalent compound. Similarly, water is formed by 2 hydrogen atoms and 1 oxygen atom. Oxygen is more electronegative than hydrogen, so it tends to attract the shared pair of electrons. So oxygen gets a slight negative charge, and the 2 hydrogen atoms, they get a slight positive charge. So water is a polar covalent compound. But what happens if the 2 dogs who are fighting and they have 1 bone each, they have equal strength? So when the 2 dogs are of equal strength, nobody lets the other one pull the bone more towards itself. So even in atoms, when the 2 atoms are of equal electronegativity, in this case, nitrogen combines with another nitrogen atom to form a covalent compound. But in this case, both the nitrogen atoms have equal electronegativity. So there is no charge separation between the 2 nitrogen atoms, as they equally share the shared pair of electrons. Such covalent compounds are known as non-polar covalent compounds. So for example, we have HH or OO and nitrogen-nitrogen. These covalent compounds that are formed, the shared pair of electrons are equally shared between the 2 atoms. There is no charge separation, so such covalent compounds are known as non-polar covalent compounds. Is O2 a polar covalent compound or a non-polar covalent compound? We know that O2 is formed by a double covalent bond. Both the oxygen atoms are of equal electronegativity. So the shared pair of electrons are equally shared by the 2 atoms. This is the reason why O2 is a non-polar covalent compound. So the non-polar covalent compounds are those in which the 2 atoms have little or zero electronegativity difference between the 2 atoms. Let's take an important case of CCl4. CCl4 forms a covalent compound. Each carbon, in this case we have only 1 carbon atom which has 4 valence electrons. Each chlorine atom has 7 valence electrons. Now each chlorine atom needs 1 more electron to satisfy the octet rule. So it shares 1 electron with the carbon atom. So we can also show the remaining electrons. So this is the covalent compound CCl4. What is happening in this case? Each carbon and chlorine atom is sharing 2 electrons. Now in this case, we have different types of atoms. The electronegativity of chlorine is greater than that of carbon. So it tends to attract the shared pair of electrons towards itself. So now the chlorine atoms, they become slightly negatively charged, and the carbon atom becomes slightly positively charged. But in this case, chlorine atom is slightly attracting the electrons towards itself from this side. And at the same time, this chlorine atom is attracting these shared pair of electrons. So overall, the attraction between the two is cancelled or nullified. Similarly, this chlorine atom is attracting the shared pair of electrons towards this side, and this chlorine atom is attracting the shared pair of electrons towards this side. Since both are equal and opposite, so even this effect is nullified. So overall, the CCl4 molecule is non-polar. This is a covalent compound. If we take any two atoms, if we take one carbon and one chlorine, there is charge separation. So this is a polar covalent compound. But when we talk of the entire CCl4 compound, since the effect of the electronegativities is nullified, overall CCl4 is a non-polar covalent compound. So when there is bond formation between two types of atoms having the same electronegativity, when they have the same electronegativity, the type of bond formed is a non-polar covalent bond. When there is a little electronegativity difference, the bond formed is a polar covalent bond. And when there is a large electronegativity difference between the two combining atoms, the type of bond formed is an ionic bond. So electronegativity plays a very important role in determining which type of bond is formed between two atoms.